We're going to talk about special segments with triangles today. First, we're going to talk about what they are and what kind of properties they hold for triangles, and then we're going to look at some applications. The first one that we're going to talk about is an angle bisector. So an angle bisector, if we have that triangle and we cut that angle in half from the vertex, so we have this angle being bisected here, and it cuts it into two congruent angles. Next, we have what's called an altitude. An altitude is the height of a triangle. Now, we have a couple different cases here. We have our altitude where it's just straight down from a vertex and it's contained inside the triangle. Then we have another case where we might have an obtuse triangle and we can drop that altitude from that vertex straight down and it's outside the triangle. Okay, then we have our median, means middle. The median means that it cuts the side in half. So when we have that median segment, this side right here is bisected and we have two congruent segments there. And then this last one is perpendicular bisector. And we have a couple of different examples of what a perpendicular bisector does, and it may or may not be completely contained inside the triangle. Okay, so let's look at some examples. If I have a median, if I go back up here, a median cuts the side in half. So what that's going to mean for this triangle here is that G is my midpoint. And if G is my midpoint, that means that these two segments, AG and GC, keep wanting to write B, let me just rewrite that. AG is going to be congruent to GC. So if those two are congruent, I know the expressions that represent them are also congruent or also equal. AG is 6x plus 4. CG, or GC, is 7x minus 5. Now I just solve for x. Okay, so I subtract 6x from both sides. So 4 equals x minus 5. Then add 5. So I'm going to come over here. X is going to equal 9. Okay, let me erase some of this. You can always go back and pause and look at some of that stuff again. Alright, given that AF is an altitude, being an altitude means that we have a right angle. Those two segments, the side that it touches and the altitude, are perpendicular. So that means here that angle 2 is going to be a right angle and angle 1 is going to be a right angle because AF is that altitude. So I know that the measure of angle 1 is 90 degrees and the measure of angle 2 is 90 degrees. Well, if I know the measure of angle 1 is represented by 8x plus 18, I know that 8x plus 18 must equal 90 degrees. Okay, so I'm going to subtract 18. So I have 8x equals 72. Divide by 8. And I get x equals 9. An isosceles triangle case. An isosceles triangle is a special case. You need to put a star by this. This is something you need to remember. Okay? An isosceles triangle has a special property when drawing that segment from the vertex angle. So this is my vertex angle. And B and C are my two base angles. When I draw that segment here, AD, from that vertex angle to the side, that segment AD is an angle bisector, it's an altitude, it's a median, and a perpendicular bisector. It's all four of those segments. Now, because it's an angle bisector, we actually have some different properties, or we have some different angles that are congruent. So because it's an angle bisector, angle A here is being cut in half, so angle BAD, that angle, is congruent to angle DAC, which is this angle. Okay. Now, because it is an altitude, I have that AD, the segment, that's my altitude, is perpendicular to the side of the triangle BC. Those two segments form that right angle. Now, because this is a median, that means that D is the midpoint of this side, and that BD and DC are congruent. Now, this only works from the vertex angle. If I were to draw one of the other segments like this, it doesn't quite work. That's not necessarily the midpoint, and so it only can be drawn from that vertex angle in order to be all four. All right, in example 3, we're actually looking at an isosceles triangle, and we're trying to solve some things here. Now, I'm going to be writing stuff down and then erasing, so if you want to go back and look at something again, just pause and rewind the video. So, I'm first going to draw on my picture what this tells me. I know that this is an isosceles triangle, so I know that AB and BC are equal. I also know that BD is an angle bisector. That means that these two angles are congruent. Now, if those two angles are congruent, I then know that this segment is actually a median, a perpendicular bisector, and an altitude. So that means that I have a right angle right here. That also means that these two segments, AD and DC, are equal. That's going to help me here when I'm trying to solve for angle 1, angle 2, and angle 3. So what I'm going to solve for first is I'm going to solve for x. I notice that angle 1 has an x in it, so I have the measure of angle 1. And angle 2, so I know I'm going to be dealing with the measure of angle 1 and the measure of angle 2. Because this is an angle bisector, I know those two are equal. So if the measure of angle 1 is represented by 6x plus 7, and the measure of angle 2 is 3x plus 16, I know I can set those equal to each other and then solve for x. So I'm going to subtract 3x plus 7 equals 16, subtract 7, 3x equals 9, divide by 3, so x equals 3. Okay, so I'm going to write that over here. I now know that x is 3. Now I'm going to solve for z. The only reason I'm doing that is because it's a little easier to solve for z before we solve for y. Now notice where the z's are. I have a z here in AD. And a z here in DC. Now, because I know that this segment BD is also a median, I know that AD is equal to DC because each one of these properties hold for that isosceles triangle. So I know 2z plus 1 is equal to 5z minus 8. So I'm going to subtract 2z. let me erase that plus. Equals 3z minus 8. Add 8. So I get 3z equals 9. Divide by 3. So z is 3. Okay, lastly, I need to solve for y. Now y is in angle 3. Angle 3 is here. I just solved for x and z. And notice the measure of angle 1 is 6x plus 7. So I can find the measure of angle 1. 6 times 3 plus 7. 6 times 3 is 18. 18 plus 7 is 25. That means that angle 1 is 25 degrees. Now what I notice here is that I have a triangle formed with my 25-degree angle, my right angle, and angle 3. So I know the angles in a triangle equal 180 degrees. So I know that 90 plus 25 is going to give me 115. So I know 180 minus 115 gives me 65. 65 degrees is the measure of angle 3. So if I now have the measure of angle 3, I have enough information to solve for y, because I can set y minus 1 equal to that 65 degrees for angle 3. So now I'm going to add 1. 3y equals 66, so y equals 22. So now I have each of the variables solved for. Okay, we're going to talk about coordinate planes next. So we need to remember a few concepts. We need to remember what midpoint is. Okay, midpoint means in the middle. To find that, you have to do x1 plus x2 divided by 2. And y1 plus y2 divided by 2. So I'm going to add my two x values together. Negative 1 plus a negative 5 is a negative 6. Negative 6 divided by 2 is a negative 3. That negative 3 is going to be the x value of my midpoint. Now I'm going to do the same thing with the y's. Negative 10 plus a negative 8. Negative 10 plus a negative 8 is negative 18. divided by 2 gives me a negative 9. That negative 9 becomes the y value. If I were to plot these points, that negative 3, negative 9 would be right smack in the middle of segment AB. Okay, I need to remember how to find slope. That's y2 minus y1 divided by x2 minus x1. So I'm going to subtract my y's. Negative 8 minus a negative 10 over negative 5 minus a negative 1. Okay, so according to integer rules, what I do, keep, change, change. So negative 8 plus 10 is 2. Negative 5, keep, change, change. Negative 5 plus 1 is a negative 4. So negative 2 over 4 is a negative 1/2. So that's the slope. If I want to find the slope of a segment that's going to be perpendicular to that, I'm going to have to find the negative reciprocal. That means I'm going to flip and change the sign. So if I have a negative 1/2, I'm going to flip to be 2 over 1, and the sign of 1/2 is negative, so the new one's going to be positive, and 2 over 1 is just 2. Okay, so in example 5, 6, and 7, we're dealing with this triangle. So I'm looking at finding the coordinates of the median connecting point A to side BC. Okay, so I have to remember what being a median means. Being a median means I am connected to the midpoint of the side that's opposite that vertex. So I need to find the midpoint of segment BC. So to do that, I need to find the points. So point B is 3, negative 1, and C is negative 3, positive 5. So I'm going to find the midpoint by adding the x's together. So 3 plus a negative 3, and then dividing by 2. 3 plus a negative 3 is 0, divided by 2 is 0. So I know the x value of my midpoint is 0. Okay, for my y values, 5 plus a negative 1 over 2. 5 plus a negative 1 is 4. 4 divided by 2 is 2. So the coordinate of my midpoint of BC is 0, 2, which is here. Now if I were to draw the segment between those points, that would be the median from A to BC. Now I'm going to figure out example 6. I want to find the coordinates of the altitude connecting C to, and this is supposed to be AB. I want to go from C to AB. Well, being an altitude means that I need to be perpendicular. So being perpendicular means I'm dealing with slope. If I look at AB, the slope of AB is equal to 0. That means it's a horizontal line. So the slope of a line perpendicular to that has to be the slope of a vertical line. The slope of a vertical line is undefined. Well, that means that I need a vertical line from C all the way down to AB. So the point of my altitude is negative 3, negative 1. Now, for this last one, what is the slope of the perpendicular bisector? Again, remember that perpendicular means that I want to have negative reciprocal slopes. I want the perpendicular bisector of BC. That means I need to make a right angle with side BC. So I need to find the slope of BC and then find the negative reciprocal. So I have up 1, 2, 3, 4, 5, 6, and left 1, 2, 3, 4, 5, 6. That's a negative 6. So the slope of AB is 6 over a negative 6, which is really just negative 1. So I need to find the negative reciprocal of negative 1. So negative 1 is really just negative 1 over 1. So flip that and you're going to get 1 over 1. This has a negative, so this is going to be positive. Positive 1 over 1 is just 1.